Okay, in this new problem, we're still going to be finding volume for a cone in this case, but we're going to have to use trigonometry to find the volume. Our formula will be the same. Formula will be 1/3 area, not area of the base, pi r squared, which is the area of the base, times the height. In order to figure out our radius, which is not given to us, we have our height, which is 16, and we have this angle. In order to find this radius, we're going to have to use either sine, cosine, or tangent. In this case, we have opposite and adjacent, so it's tangent. So we would say tangent of 65 degrees is equal to opposite, which is 16, over adjacent, which is r. Remember, we can just flip-flop those, and we would get r is equal to 16 over tangent 65. We're going to punch that in on our calculator. Should get about 7.46. Remember to keep that number on your calculator. We want to use that. So again, let me just do this real quick. We're going to plug it into our formula. We get 1/3 times pi, and this is 7.46 squared, and the height is 16. Remember, just use this on your calculator and just square the number that you have, multiply that times 16, and multiply that answer times pi, and then we're going to divide that answer by 3. If we do all of that, we should get approximately 932.68 cubic feet. Okay? So again, we have opposite and adjacent. That means we have to use tangent here. We plug in our values, we simplify it, and we get our answer of 7.46. We plug everything in, we get 932. They got 0.45. It's because they use this. I don't want you to do that. I don't want you to use 7.46. I want to use what's on your calculator. So you should have gotten 732.68. Okay? All right, here's another one where it's two different shapes together. So we have to find the volume of each part and then add them together. So let's call this top part right here, let's call this volume 1, and we'll call this cube down at the bottom, we'll call that volume 2. So for the first one, we're going to have to use 1/3 area of the base times the height. Now the area of the base for that pyramid, it's 6 by 6 because it's a square. So it'd be 6 times 6, or 36 square meters. To find the height, we notice the height of the pyramid is 6 as well. This gives us what we need. We have 1/3. This is 36, and this is 6. If we divide the 36 by 3, we get 12. 12 times 6 gives us 72 cubic meters. Okay, for volume 2, it's going to be area of the base times the height. You notice the area of the base is the same and the height is the same. So in this case, we would get 36 times 6, and that gives us 216 cubic meters. Now we're going to find the total volume. Total volume would be volume 1 plus volume 2. So in this case, it would be 72 plus that 216. And if we add those together, we would get 288 cubic meters. Okay? So again, volume of solid is the cube and the pyramid together. So this is S cubed, or you could have said still area of the base times the height. So here we get 6 cubed and 6 squared and 6. We get 216 and 72, which is our 288. So it's 288 cubic meters. For this next one, it's sort of an applied problem. What we're going to have to do if we look, 1 milliliter is the same as 1 cubic centimeter. So when we do this, we can write it in terms either way. Let's see. So we want to find the flow rate of the sand in millimeters per second. It says it takes 2.8 seconds for the sand to empty out of the funnel. So the first thing we want to do is figure out the volume of the funnel. And let's see. So we're going to use 1/3 pi r squared times the height. So in this case it's 1/3 pi times the radius, which is 4 squared, and the height is 6. I'm going to simplify the 6 and the 3 and give me 2 here. 4 times 4 is 16. 16 times 2 is 32. So it's 32 pi cubic centimeters. If we get our calculator out and figure out what 32 pi is, and do 32 pi, we get approximately 100.53 cubic centimeters. And remember, this is also the same as 100.53 milliliters, because it says that they're equivalent. And we know it takes 2.8 seconds. So if we're doing milliliters per second, we would take, for the flow rate, we would take that 100.53, which is milliliters. We divide it by, I believe it was 2.8 seconds. 2.8 seconds. We divide it by 2.8 seconds. That gives us milliliters per second. So if we divide those two, I'm going to get my calculator out again. Again, use the number that's on your calculator, not 100.53. And you get approximately 35.90 milliliters per second. So again, find the volume. Plug it all in. They said about 101, which is the same as milliliters. And then we just divide those two. I got 35.9. Because they rounded so much it messed it up. Use the numbers that I've shown you, okay? So 36.07, or what I said. Here's another one with a cone. We have 40 degrees here. We want to know what this radius is, because our formula will be 1/3 pi r squared times the height. So we're going to have to use, since that's 40 degrees, this is r, which is opposite. 5.8 is adjacent. Again, tangent. This time they gave us the top, so it's tangent of 40 degrees. Opposite is r. Adjacent is 5.8. So this time we multiply both sides by 5.8. 5.8's cancel. We get r is approximately... Give me a sec. 5.8 times tangent of 40, which should be about 4.87. Keep that on your calculator. We get 1/3 here. We know the height is 5.8, so we say pi times 4.87 squared. So we're going to square that. And we're going to multiply that times 5.8. So times 5.8 times pi, and divide by 3. We should get, if we did all of that, 143.86 cubic inches. So 143.92. It's because they rounded here. We didn't. We got a better answer. And here's another one. We have a right cylinder, and on top we have a right cone. I'm not going to draw a picture. We'll just do this. So we want to find the volume of the cylinder, and we want to find the volume of the cone, and then add those two together. We know that the radius here is 3 and the height is 10. So for the cylinder, it would be pi times 3 squared times 10. 3 squared is 9, so that would give me 90 pi. And I'm actually going to keep it in terms of pi. The right cone on top has the same base, so since it's 1/3 pi, it would still be 3 squared, and the height this time is 5. We can't really divide here, so 3 squared is 9. 9 times 5 is 45. 45 divided by 3 ends up being 15 pi. Okay, so then we're going to add those two together. The total is going to be 90 pi plus 15 pi, which is 105 pi. Now we get our calculator out. So we're going to do 105 pi. Ends up being 329.87 cubic centimeters. Okay? They say about 330. Ours is better. Oh wait, what did it say? Round to 2 decimal places. So that's completely wrong. Ours is correct. Alright, and so for the other one, it says, suppose a different kind of sand is used. It takes 3.2 seconds. If we go back a couple pages, we found out that the volume of this was 100.53 or 32 pi. So again, we found out the volume was 32 pi milliliters. And it says it takes 3.2 seconds. So the flow rate would be that 32 pi milliliters over 3.2 seconds. And remember, this was like 100.53 or something, but use the 32 pi. So I'm going to do 32 pi and divide that by 3.2 seconds. We get approximately 31.42 milliliters per second. And that should just be a point. Again, they rounded, so theirs is off, ours is correct. And we're done. Thank you.